Good morning, my dear students. This is Virat Kumar, lecturer in Electrical and Electronics Engineering from the Institute of Government Polytechnic, Vaddepalli, with the semester of 4, from the subject of AC machine with a code of 18EE403C, and the main topic is three-phase transformers, and the subtopic we are going to see today is cooling of transformers. Cooling of transformers. So a small recap of previous session, that in the previous class we have learned about Scott connection, applications of Scott connection, advantages of Scott connection, disadvantages of. So these are the things which we have seen in the last or previous class. The today's main objectives are: on completion of this period, you will be able to know necessity of cooling of power transformer, and methods of cooling, and specifications of oil used for cooling. See, cooling is one of the major topic in the transformers, that in every transformer required a cooling, otherwise the transformer might get damaged, or it may blast also. It may leads to blast also, like a big transformers where power transformers in substations will have a huge heat generation in it. So in order to control that, we need to cool down the transformer. So this is the main topic of a transformer. So that is why we are going to see now about necessity of cooling of power transformer and methods of cooling. So since there is a cooling required, we also have some methods. There will be a single or two methods. We'll be having some many methods. So we'll be seeing methods of cooling. So for cooling, generally we use oil in the transformer. So what kind of oil, what is the range of it, like dielectric strength and all those things. So we'll be seeing specifications of oil used for cooling. So firstly we'll be seeing necessity of cooling transformer. We know that transformer will have iron loss and we know the transformer will have iron loss and copper loss, and these losses produce heat. The heat should be removed from the core and windings for smooth operation, and to run the transformer at its rated capacity efficiently, effectively and continuously, cooling is required. So we know that the transformer will have mainly the iron losses and copper losses. So these losses will produce large heat in the transformer, and that heat should be removed from the core and windings for smooth operation. And to run the transformer at its rated capacity efficiently, effectively and continuously, so the cooling is required. So moving on to the next slide, cooling. So to extract the heat from the transformer core and winding, the transformer oil is used. So we have said that there is a cooling is required compulsorily and it is necessary, and that heat is extracted from the transformer core and windings. The transformer oil is used. The oil is called transformer oil. I will see the name of it, chemical name and trade name, all those things. So in generally we use transformer oil to extract that heat from the transformer core and windings. So this transformer oil serves two purposes. One is it improves the insulation strength and it extracts the heat from core and windings and conveys to the atmosphere. So this is the thing done by the transformer oil. Transformer oil serves two purposes. One is to improve the insulation strength and the other is to extract the heat from core and windings and convey to the atmosphere. It extracts the heat and it just conveys all that heat into the atmosphere. So moving on to the next slide, methods of cooling. Cooling of transformer is done by two types. One is dry type transformer, that is AN method, that is air natural. So generally for cooling we just use dry type and wet type. Actually dry type, obviously you know that it is done by air, and a wet type is obviously done by oil. So there are two cases here. So cooling of transformer is mainly done by two types. One is dry type and the other is wet type. In dry type, AN method is used, that is air natural, or forced air is also obtained by the fans and all those things. So in this dry type transformer we use AN method, that is air natural, and AF method, air forced. So these two cases are involved in dry type. One is air natural and air forced. Air natural is obviously obtained from the atmosphere, and air forced we need to induce some air, that is done by fans and all those things, fans, blowers and etc. And the other is wet type or oil immersed type transformer. Oil immersed means the transformer is just dumped into the oil, that is oil immersed. That means transformer is immersed in the oil. So that is why it is called oil immersed type transformer. So in that ONAN method, that is oil natural and air natural. ONAN, oil natural and air natural. And the other is ONAF method, oil natural, air forced. And the other is ONWN method, oil natural and water natural. And the other is OFNA method, oil forced and natural air. And the other is ONWF method, that is oil natural and water forced. And last but not least, OFAF method, which is oil forced and air forced. So we can just see the difference in these methods, and we have given you some shortcuts. ONAN, O is oil and A is air. So simply you can just remember them. ONAN is oil natural and air natural. This method ONAF, oil natural and air forced. So from this method to this, so the difference is here is air natural and here is air forced. If this kind of cooling is not sufficient to the transformer, then we need to induce some more cooling, so that is why air is forced. And if this is also not sufficient, we'll move on to the next, that is ONWN, that is oil natural and water natural. So then air, if we just, water is the best coolant than air. So we'll move on to the ONWN, that is oil natural and water natural. And after that OFNA, that is oil forced and natural air, or AN. We can write OFAN, oil forced and air natural. So oil is forced in it. And next ONWF, oil natural and water forced. Previously water natural and now it is water forced. And OFAF, that is oil forced and air also forced. So these are some oil immerser type transformers cooling methods. So moving on to the next slide, first we'll see air natural cooling. In air natural cooling, the heat is dissipated to the external atmosphere by the natural circulation of air. The transformer core and windings are open all around to air. And this method is used for cooling very small rating transformer, which is of about or up to 25 kVA. So air natural is done automatically from the atmosphere itself. So the heat is dissipated to the external atmosphere by the natural circulation of air. And the transformer core and windings are open all around to air. And this method is used for cooling very small rating transformer up to 25 kVA. Moving on to the next slide, air forced cooling. In this method, cooling is improved by using continuous forced air produced by a forced draught fan. Previously I have said you that is done through fans. That fan is called forced draft fan. The forced air is filtered to avoid dust entering the ventilating ducts. The hot air is discharged through the top of the case. So here you can see from air natural to air forced that here cooling is improved by using continuous forced air produced by a forced draught fan. And the forced air is we just pump some air through some forced draught fans, but when the air is pumped we will be getting dust and all those things, etc. So in order to avoid the dust we need to filter it, or else the transformer may uh, be struck with all the dust and gets damaged. So in order to avoid that, the forced air is filtered to avoid dust entering the ventilating ducts, and the hot air is discharged through the top of the case. And now moving on to the oil natural cooling. You can see the diagram over here. This is the transformer core with the radiators, nothing but transformer tubes, we'll just call it as tubes, and there is a transformer core with all the windings like LV and HV. So there is an oil in the transformer. First the oil is poured and then this core is immersed into the core, immersed into the tank. So that means it is continuously in contact with the oil. That is, the oil gets circulated continuously. So you can see the arrow marks that indicates the circulation of oil from the tank to the radiators and from the tank to the radiators, similarly on the either side. So we'll see some theoretical top part of this oil natural cooling. So if the air cooling is not sufficient, so previously we have seen air natural and air forced. If that type of cooling is also not sufficient, then oil natural cooling method is employed. Then oil natural cooling method is employed. The transformer is immersed in a tank filled with transformer oil. The transformer is immersed in a tank. We have seen in the previous diagram. The transformer is immersed in a tank filled with transformer oil. And the oil absorbs the heat and transfers to the atmosphere through the tank surface. Radiator tubes are used to increase the surface area and hence cooling is more efficient. The oil level in the tank should never fall below the upper ends of the tubes. So moving on to the next slide. Oil natural air forced cooling. You see the diagram over here. The oil is in natural way and air is in forced. So this is called oil natural and air forced. You can see There are some fans attached to this tank. You can see the fans over here. These fans are called forced draught fans. So through these fans the air is blown forcefully. And moving on to the concept of this, oil natural air forced. So in this, the transformer is immersed in the oil to cooling is improved by forced air over the outer surface of the radiating tubes, and this additional cooling is provided by heavy duty electric fan mounted external to the transformer. So this is about oil natural and air forced. So this additional cooling is provided by heavy duty electric fan mounted external to the transformer, as we have seen in the previous PPT. Now here oil forced and air natural. Here the oil is forced and air is natural in contact. The transformer is immersed in oil and cooling is affected by forced oil circulation through motor driven oil pump. The radiators may be kept away from the transformer, and oil is cooled in a radiator by natural circulation of air. So this is called oil forced and air is natural. And you can see the diagram over here for oil forced and air natural. A rigidity, you can see the some readings. The oil temperature of 80 degrees centigrade and cooling level is 4. So when this oil is forced and air is in the natural way, that means oil is forced to the radiators in order to circulate by spreading the surface area through the radiators, and by the natural air it gets cooled. That is oil forced and air natural. and oil forced and air natural. In this you can see the transformer. Moving on to the next slide. Here it is oil forced and air also forced. Both oil and air are forced. You see the diagram over here, and this is the transformer core, and inside there is a transformer with core and windings. These are bushings with the conservator, and this is the oil or heat exchanger. And there is a like heat exchanger means that is these may be called as radiators also, and there is a forced draught fan connected to the bottom of that. And there is a oil pump connected to the wall. So this oil pump pumps the oil forcefully, and air is forced by the fan. Oil is forced by the pump and air is forced by the fan. So that is why this is called oil forced and air forced. Coming to oil forced and air forced, in this the cooling of oil forced and air forced type transformer is improved by employing air blast over the radiators. Air is blasted by the forced draught fans which are below the radiators. So that is why he is saying that the cooling of OF-AF type transformer is improved by employing air blast over the radiators, as you have seen in the previous slide. Moving on to the next slide. Oil natural and water natural. ONWN, oil natural and water natural. So in this kind of cooling, the transformer is immersed in oil and cooling is improved by circulation of water through tubes placed inside the upper portion of the tank. The transformer is immersed in oil and cooling is improved by circulation of water through tubes placed inside the upper portion of the tank. Cool water is passed through the tubes by a pump, and the heat of the oil is carried away by this cool water. The heat of the oil is carried away by this cool water. So here oil is also natural and water is also natural. Moving on to the next slide. Oil forced and water is also forced. Oil forced, water forced. For effective cooling, here oil is also forced and water is also forced. As in the previous cases, we have seen oil pumps. Through the oil pumps, we can force the oil, and through the water pumps, we can force the water. So cooling is similar to that of OFAF, that is oil forced and air forced, with the difference that oil is cooled in an external radiator by water instead of air forced. So the radiators are dumped in the water, or else the water is sprayed on the radiators instead of air forced. The water is forced. Sprinkled water is forcefully sprinkled on the radiators. So this is about oil forced and water forced. Moving on to the next slide. Oil forced and water forced. So transformer oil water coolers of double tube technology for 400 MVA transformer. This is oil forced, water forced. And now coming to the specifications of oil used for cooling as per IS 335 1983. IS is Indian standards. As per Indian standards, this is number 335 in the year 1983. And you can see the characteristics and requirement. The first one is density at 27 degrees centigrade max. The requirement is 0.89 grams per centimeter cube. Kinematic viscosity at 27 degrees centigrade minimum value is 27 cost. And interfacial tension at 27 degrees centigrade minimum is 0.04 Newton per meter. And flash point, the minimum value is 140 degrees centigrade. And pour point maximum is -9 degrees centigrade. In continuation with the specifications of oil used for cooling, same characteristics and requirement. Neutralization value for total acidity maximum is 0.03 milligrams KOH per gram. And corrosive sculpture is non-corrosive. And dielectric strength minimum value is 50 kV for RMS, 50 kV of RMS value. And water content, the maximum value is 50 ppm by weight. The water content maximum value is 50 ppm by weight. So this is the things, characteristics and requirement of some specifications of oil used for cooling. So this is about the today's session, and we'll see a summary that we have discussed about necessity of cooling of a power transformer, methods of cooling, and specifications of oil used for cooling. So by this we have understood that the cooling is a very essential part in a power transformer. So let's see a small quiz. Cooling a transformer is necessary to increase the efficiency, dissipate the heat generated in the windings, reduce the losses, and reduce humming. So out of all these four, the cooling of transformer is necessary to dissipate the heat generated in the windings and the core actually. So the answer is dissipate the heat generated in the windings, as you can see. Going on to the next question. Oil in a transformer is used for insulation, insulation in cooling, lubrication, none of these. It's very simple, as we have learned that oil is used for two purposes. One is for insulation and also for cooling, mainly for cooling and for insulation. So the option is B. We'll just see. So you can see over here it is for insulation and cooling. It is for insulation and as well as for the next question. The type of oil which is suitable as transformer oil is animal oil, cooking oil, mineral oil, vegetable oil. Actually this was not in the previous slides, but I'll just tell you the answer that the type of oil which is suitable for transformer oil is mineral oil, not animal oil or cooking oil or vegetable oil. It is mineral oil. You can see here it is a mineral oil. Actually the name of the oil is, the chemical name of it is pyrochlor and the trade name is askrels. The chemical name of the oil is pyrochlor. It is a mineral oil. That's it for the quiz. We'll see the frequently asked questions in it. They explain the necessity of cooling, list the methods of cooling a power transformer, describe methods of cooling a power transformer with figure. So these are some frequently asked questions. So that's it for the session. I hope you have got all the points. So finally, thank you one and all.